Okay, most of us have a bad habit, and that is once we learn calculus, we'll just try to use calculus to solve all the questions whenever possible. That's not good, because for example, sometimes if you want to find the minimum or the maximum value of some function, you don't have to take the derivative all the time, because you might be able to just use some inequalities to help you do so. So in this video, I want to share 3 inequalities that we should keep in mind so that they can help us to find the minimum or the maximum of some functions in the future. Start off by the triangle inequality. This is the one with absolute values. I will write down absolute value of A plus absolute value of B is greater than or equal to absolute value of A plus B. And this right here is true for all A and B in the real numbers. Okay, here's the thing though. You use this quite a lot if you are doing the epsilon delta definition of a limit. But in this video, we're talking about the minimum value or the maximum value of some function. So let's take a look at an example. Suppose we have the function f of x is equal to absolute value of x plus 2 plus absolute value of x plus 3. And we would like to find the minimum of that function. Okay, let's see. I gave you the absolute value right here, so that's like the first one. And likewise, this is the second one. So we can just apply that right away, huh? So we are saying that this right here should be greater than or equal to absolute value. This is like the A, so put that down. And then we add that with, this is like the B, so we put that down inside here. Combine like terms inside. This is equal to absolute value of 2x plus 5. Okay, so far so good, nothing wrong with it. Okay, let's think about this. We have absolute value of a linear function. The vertex of this is at negative 5 over 2 because that's like the break-even point, right? Like that. So when x is equal to negative 5 over 2, the inside is 0, absolute value of 0 is 0. So the minimum of this is equal to 0. So what we are saying so far is that this function is greater than or equal to 0. So does that mean the answer for this question is just equal to 0? Well, it's not correct. Because so far what we have shown is that this function is greater than or equal to 0. But if you want to say the minimum value of a function, we have to make sure the function can actually achieve that value. This is always greater than 0, but it can never be equal to 0. Okay, so why did I show you the triangle inequality if it didn't really help us with the first example? Well, let's talk about the problem here. The reason that this didn't really help is because this right here is still a function. We still have the x. We don't want that. Here, let me show you how we can do it. F of x is still equal to absolute value of x plus 2 plus absolute value of x plus 3. Well, if you just put them inside of this one big absolute value, x plus x gives us 2x. We don't want that. What if we have negative x right here instead? Wouldn't that be so nice? Yes. So we can do the following. I'm going to keep the first one as how it is, but for the second one, since the absolute value of negative something is the same as absolute value of that thing itself, I'm just going to be multiplying by a negative to the x plus 3, like this. And then if you take a look, this is still legitimate, and that's going to be negative x minus 3. This and that are the same thing algebraically. So far we have done nothing with the inequalities. Now check this out. Take this for the A. Take this for the B. By using the triangle inequality, we will know that this is greater than or equal to one big absolute value, and we have x plus 2 plus the B is negative x plus 3. And then combine like terms, this is equal to, they cancel, and then 2 minus 3 is negative 1. So this is just equal to 1. And I will tell you, in fact, this right here does have the minimum value equal to 1. This is in fact 1. How though? We still have to show that this can achieve 1. And to do so, you will just have to solve absolute value of x plus 2 plus absolute value of x plus 3 being equal to 1. And I will tell you, you can just look at this right here as well. If you make this equal to 0, x is equal to negative 2. If you plug in negative 2 in here, 3 minus 2 is 1, absolute value of that is 1, it's achievable, right? And then if you put negative 3, you will make this 0, and this is absolute value of negative 1, so you will still give you that. The interesting part of this right here is that I will tell you, as long as x is in between of negative 3 and negative 2, you will always get 1. If you want to see a detailed explanation by using inequalities or the idea of distance, you guys can check out my other video for it. But the discussion here is that once you can show that the function can achieve this value, then you can say that this does have the minimum value. So the first one is the triangle inequality. Now, here's the next one. Okay, for the next one, I will present you guys the Cauchy-Schwarz inequality, which says the following. I will give you guys this version. It says a squared plus b squared times c squared plus d squared. This is greater than or equal to a times c plus b times d, and then you square that. And this right here is true for all a, b, c, d in the reals. And you can prove this if you have done some factors. This is actually just from the dot product formula. I can talk about that in another video. But let's see how we can use this inequality to help us solve some calculus type of question. Right here, I would like to ask you the following question. Suppose we have this right here. Let's say 3x plus 2y is equal to 4. Then we would like to find the minimum value of, let's say we want x squared plus y squared. It does sound like a total calculus question, right? This is suggesting us to solve for the y from this equation and then plug into here and then take the derivative and then set it equal to 0 and so on, right? But you don't have to do so. The reason why is because, have a look. 3x plus 2y, it's like this part right here. Put the a to be the 3 and the c to be the x. Likewise 2 and also the y. And another hint that will suggest you to use the Cauchy-Schwarz inequality is because we have the square. That might also be a hint. So have a look. I'm going to start from here. This is just like the a and then the c, and then this is like the b and also the d. So by Cauchy-Schwarz, we will know that a squared, which is 3 squared, plus b squared, which is 2 squared, and this is just going to be a constant, which is very nice, times c squared, which is x squared, plus d squared, which is y squared. This is exactly what we're trying to find right here. And it is going to be greater than or equal to this part, which is 3x plus 2y, and then you square that. Now, the inside here is really just going to be the given value 4. And then right here we can work that out. This is just going to be 9 plus 4, which is 13, and then multiply that by x squared plus y squared, and that's greater than or equal to 4 squared, which is 16. And as you can see, we can divide 13 to both sides. X squared plus y squared has to be greater than or equal to 16 over 13. Now we have to be super careful. Can we just say this right here is the minimum right away? And by the way, I said this is the minimum is because this is always greater than or equal to that. So this is the smallest. But can you just say that? Remember the example that we did earlier? I showed something is greater than or equal to 0, but the 0 is not the minimum value of the function. because we have to make sure our function here can actually achieve this value. Otherwise, I can say this is greater than or equal to negative infinity. But don't do that. So, when we have this inequality, we will also have to make sure the equality situation. Right here, I will tell you the equality holds if A over C is equal to B over D. It's like A divided by C, B divided by D. So this right here is what we will have to check. We will have to check that A divided by C, which is 3 over X, can this be equal to 2 over Y? Is this achievable? Okay, this is what we have. Well, we still need to figure out the Y. From this equation here, if you just do that 3x plus 2y is equal to 4. Move the 3x to both sides. This is 2y is equal to 4 minus 3x. And then divide both sides by 2. Y is equal to 4 minus 3x over 2. So I can put this right here. So we are checking 3 of x. Can this be equal to 2 over the y, which is 4 minus 3x over 2. Alright, and then the rest is just kind of like doing the algebra. So let me clean this up. This is 3 over x. Can this be equal to, put that to the top, is 4 over 4 minus 3x. And then just do the rest. This times this times that. So we're saying 4x. And then this times that, which is distribute, so that's 12 minus 9x. And if you put this to here, it's 13x is equal to 12. X is equal to 12 over 13. And once you have that, you have the y, and I'm just going to tell you guys whatever that is, right? And I will tell you, once you worked out the y value, if you square this and then plus the square of that, you will end up with 16 over 13. But I just want to show you that it's achievable. And once you show that, then you can be sure that this is the minimum. And well done. And this is for your homework, so make sure you do it. Now, there's one more inequality that you should definitely keep in mind. And that's this one right here. Number 3, we have the AM, GM inequality. The A stands for arithmetic, G stands for geometric, the M stands for mean, which is just like the average. So let's say we have two numbers. To find the arithmetic mean, we just add them and divide it by 2. And to find the geometric mean of two numbers, we multiply them and then take the square root. So this is the version with just two numbers. You can also extend this to like as many numbers as you would like. And it says that this right here is always going to be greater than or equal to that. However, we do have a small condition here. Here, because of the square root, we have to make sure A and B, they are both non-zero. And now, here is a typical question that you encounter in your calculus class. Let's say we have a function. Let's say we have 2x plus 3 over x. And we would like to find the minimum. But if you want to find the minimum when x is negative, well, you go to negative infinity. That's not what we want. So let's impose the condition that x is greater than 0, not even equal to, because we have divided by x. And we like to know the minimum. Okay, so how can we do it? Well, thankfully we have this condition, x is greater than 0. That's so nice, right? Just go ahead and take this to be the A, and take this to be the B, and then apply the AMGM inequality, and we'll be done. Have a look. By AMGM, A plus B over 2, which is 2x plus 3 of x, and then over 2. We know that will be greater than or equal to, put them in the square root and multiply. So 2x times 3 over x. This is so nice because on the right hand side, the x and x cancel. So right here we are saying 2x plus 3 over x. And we can also multiply the 2 to both sides and surpass the 2. So doesn't matter, the inequality, it stays the same thing. So 2 times the square root, and here we have 2 times 3, which is 6. What we are saying is that this right here is always going to be greater than or equal to 2 times square root of 6. And again, is this going to be the minimum? It's a lower bound, but it might not be the minimum. So again, we'll still have to talk about when will the equality hold. Well, in this case here, the equality hold, I would just say equality when A is equal to B. So to show that we can actually have that, we will have to check, can A be equal to B? Well, that's 2x being equal to 3 over x. Multiply the x to both sides, so we have, then divide the 2 to both sides, so we have x squared being equal to 3 over 2, and then take the square root to both sides. Just a positive because we want x to be greater than 0, so x is equal to positive square root of 3 over 2. If you put this in here and then work that out, I guarantee you that you get this. So this right here is achievable by that function. So this is the minimum value of that function. And we are done. Very nice, huh?